So that books and information is one of the infrastructure, if I may say that.
Yeah, that would be one of the things that leads to the issue of infrastructure. I mean, I don't know how they are today, right? But this
was a while back.
This was, yeah, it was almost 15 years ago. 15 years ago now.
Okay. Well, I think that's all. We would like to thank you, appreciate very much for your time and your advice, because this would be hopefully very useful for the coming Indonesian students.
Yeah, won't be banned from going back home.
Thank you once again.
Yeah, sure.
DJ. It's an old variety.
Vehicles, right? They are all student made.
Kira, this is all students made.
These are all student built.
All students made.
So they build this. So they compete. So it's close. This is a solar car. Solar car.
I saw one of these on the internet. It's so funny.
Did you?
The one with the
Oh yeah?
engine. Propeller engine.
And what is this?
So this area will be for you, for your new
Yeah. So this is
lab?
my new space. This is my new lab. So these are the benches. They're going to move all the computer equipment out of here to here. Research center here.
So you already did the actually in preparation?
Oh yeah. Next fall my class will be starting.
Okay. So beginning from...
Yeah. I mean, these are also old equipment. You know, that's what happens when you have the mentality of saving old things. Right? They were gonna throw these away. This is all in Tomizuka's lab. I did my PhD on this guy.
They are going to...
They were going to throw it away. That's what
you said
technology is. No, I said I'm going to use it for instructions.
Oh,
Why not?
what
These
is
are-
this
these are
again,
great
George?
motor.
What is it?
It's a direct drive motor.
I see. Okay.
Direct drive motor.
Yeah. This thing can produce. It's an electrical motor that can produce enough torque as a Corvette engine. Yeah, so that's why it's so big. But it's a motor. It's an electrical motor, right? So then they bring it in. So that robot, that's from Fanuc. No, it's a pressure sensor. That's a steam pressure sensor. So before this lab was a steam power generation lab. But nobody does steam power anymore. So. So this also is so here, see, this is the other robot that I did research on. So these are most factory robots. We can't really do research on them. Controllers will be made. So I cut that panel out, and then I did the reverse engineering, right? And did it so that I can do research on it. And then now I'm going to use that for instructions. These are the things that I did from this, right? This machine is what Malaysia bought 3 from.
Once again?
This is the machine that Malaysia bought 3 from. This is the one that I end up designing. So the robotics that's on here, I designed.
What does this one do?
It's a DNA spotter.
DNA spotter.
Yeah. So it spots DNA onto a glass slide.
Oh, okay.
And so Malaysia is going to do DNA discovery, the sequencing for the palm oil, right? So then these are like extra ones that, when GE shut down the division, they were going to throw these away. So I got a truck, and I rented the truck myself, put it in, I knew they were going to throw it away, and I brought it here. These could be instructions.
You did it personally.
Oh yeah, of course. Because otherwise they throw it away. And these are, I mean, most universities don't have robots like this. These are $16,000 motors, stages. They're just going to throw it away. But they still will work well, and students, and even graduate students can do that. Right? Same thing like this, right? I mean, these are, so, you have to have the ability to design. These are unique mechanical designs that comes in. Then you have something like this. Right?
This is all in your office, isn't it?
Huh?
Some of them were in your office.
Before, yeah, that's why I don't have my office anymore, so I'm glad I'm here. here, so this is one of my students' project.
Oh, your students' project, okay.
So this is one of their creations. This has traveled to a few places already. It went to Austin. It's gone to shows and so forth. What it does is it solves the Rubik's Cube. Right? You know the Rubik's Cube. So you can solve it.
It is one guy solved in the record.
Yeah. Yeah. This one's faster than him. This one is the current world record. It's under 7 seconds. Under 7 seconds it can solve. Because it's a machine.
Because the students like to...
And the reason for that is, like I said, so these are the examples of what comes out. Okay? There's no way. There's no way you sit here and you come up with, okay, your assignment is to solve a Rubik's Cube robot. No professor would think of it. The reason that this was thought of, because one student that was in that group was a former world record holder. That's his passion. His passion was the Rubik's Cube. Each time he comes to the office, he'll always have five Rubik's Cube in his bag. And he can solve it. And his world record holder was with one hand, not solving with two hands, with one hand.
In how many seconds?
He breaks the world record in one hand in 17 seconds.
17 seconds.
So when they started on this project, the world record was at 11 seconds.
Oh, at a time.
At the time, it was 11 seconds. So I came up and I told them, okay, well, why don't you design it for 10 seconds then? Give some headroom. Just in case by the time you build it, someone will break the record. So then, by the time they were finishing it, yes, someone did break the record. And the record was sort of like at 7.03 seconds. But when they completed it, and they fired it up, yeah, it's consistently under 7 seconds.
Consistently.
And this is using a computer?
Yeah, the computer is here.
Well, the computer is right there.
Computer's right there.
That's all it is.
So they plug in the laptop that's on there. They did all the wiring. They did all the programming.
There's
no way.
The laptop
So to talk about advancement, right? If I want to learn to solve the Rubik's Cube, I have to go to this student because I don't know how to solve the Rubik's Cube. They can scramble even till now. Even now, I have a robot that can solve it at world record, thanks to the students. But I can't. They give me a Rubik's Cube. Sebastian gives me a Rubik's Cube to solve it. I can't. And these are the things that are important because as soon as Sebastian saw this, on the way home, he asked to buy one of the cubes. Oh. Because he wanted to try to solve it. See, these exposures are important. It's important to kids. This is what I like. So we have open house and I have kids come in here. That's the funnest day. Kids to come in to run it.
Oh, I mean, this is the good thing if the students
but
have
I
that.
try to train Sebastian to do the Legos, puzzles. He's not patient.
Oh, you're not patient enough.
Yeah, he was very, very patient.
It's computerized Rubik.
You know, how the robot solves the 7 seconds.
Constantly. Yeah, with the computer, if the students bring
Oh,
the
I don't have
laptop,
the laptop. My students
plug it
run
in,
it.
and then boom.
If I knew you were $8,000 piece of equipment. Right, so you have to sit there, okay, well, that's, and that's just this. Does Indonesia have the infrastructure to get this? But here, the reputation of the university, there's 16 of these. The university didn't have to pay a dime for these. They were given by national instruments. And so far, every year that I teach here, every August, I go to Austin to their headquarters. They invite me, and they invite one.